Hey, hi everyone. Thanks for joining. My name is Darshak, and I'm going to walk you guys through what we are actually doing to expanding the RISC-V ecosystem. So I'll start with RISC-V. It started with an ISA, and ultimately it became an open standard. RISC-V, obviously everything is concentrated around designs. So, you obviously need solid designs to start with. Once you have the design, you need the verification environment. So, we got a lot of options in the RISC-V open source world to support the verification. Verification also comes with as an aid from architectural tools. So we are blessed to have a lot of reference models and test generators and other collaterals to support the verification environment. So that's the third pillar. And the last one, once you have the design ready, you would want to make sure that your software is ready. So we have a lot of open source projects that's already supporting RISC-V. And what I'm going to actually talk about is how all of these four pillars, what we are doing in each of them, and then what's exactly our contribution. So Tenstorrent, is committed to RISC-V. All of our AI cores and CPU, high performance CPU cores are actually using RISC-V ISA. I'll walk you each of these ones, but we do have open source, designs, verification collaterals, the architectural tools collaterals, and the software contribution that we are doing around the open source software tools. So we'll start with design. We do have Berkeley, Moom core based open source core that's available. So what we have done is we have taken the Moom core and added the vector support, and we have open sourced this. So we are calling it Ocelot, and right now it's available for any of you to try. And this is the vector design that was missing in the original Moom core. Going from cores to outside system IP. So we do have the DFD IP that we have just open source a couple of weeks back. So it actually uses the instruction trace from RISC-V, which it actually recently ratified, and then it's also supporting CLA and debug based traces. We are actually working to open source our PMK, so power management kit, and also the non-coherent on-chip communication IP as well. What's coming next on the design side is the support for FMA, so better floating point performance for the Ocelot compared to the Moom core. And then we are also going to open source formally verified divider that's usable with Ocelot or as a separate module. So those are on the core side, and then on the system side, we will also have IMSIC and Gen 2 of DFD, PMK, and the interconnect. So we'll talk about DV collaterals a little bit. The verification starts with test plans. We have already open sourced our verification test plans for RISC-V design. It's available right now. It's a framework and then specifies how you can actually specify scenarios for the architectural cases. And this can be used by test generators and other collaterals as the reference for your verification plan. The coverage model is actually coming pretty soon in next several weeks. That's based on the reference model, and then we will actually be supporting all the RVA 23 features by end of this year. Moving forward to architectural tools, I had a talk yesterday on RISC-V, but we have a couple of test generators. RISC-V is actually the directed test framework, and then RISC-C is the compliance test generator. So I would highly recommend you guys to actually go check it out. We have open sourced last year around 13,000 assembly-based test cases. That's available on GitHub as well. Next, on the verification side, we have the Arch checker. So it's basically the core cluster test bench that's available as open source. We use Whisper as ISS, but it's also compatible with any other ISS as long as they support the APIs. with RVFI interface. We do have DVKit that we plan to open source as well. So that actually includes the test bench, all the test generators, ISS, and a DUT that can be plugged in. So we plan to use our Ocelot as the DUT, and then it could be used with any RVFI-based RISC-V design. Reference model, I don't think a lot of people actually know that we have a fork of Whisper that was originally started with Western Digital. So we do have a fork of that actually supports all of the RVA23 profiles right now. It also supports APIs for lockstep, checking. So you can actually, run your DUT after every instruction retired. You can check the CPU state after that step. So it supports. It supports the trace-driven performance modeling APIs and also execution-based performance modeling APIs. You could run Linux, KVM, and other workloads right on top of it. We also have other reference models, IOMMU and APLIC, that's available right now, and it's available on our GitHub repository. So definitely check out all the reference models that we have available from Tenstorrent's repository. I'll talk about a little bit of workloads and software side what we are doing. So we are actually supporting multiple projects. QEMU simulator side, we have actually added support for all of our stimulus running on QEMU, but then also our Escalon-based design to support on all of the open source compilers and simulators. So a lot of work going on in supporting all of these open source software collaterals for our CPUs and then for the optimization as well. So this is at high level what all we are doing. So we have a lot of design collaterals that's already available. Same for verification side. So a bunch of things are available right now. And then coming soon is, the test plans actually, it's already open source, last week. The core arch coverage is coming next month. And then, after that, we are already working on some of the things that, on the design side, the FMA divider. We do have FPGen, not to confuse with an older tool that used to be with IBM, but we have FP APIs for generating stimulus that's going to be open source next. So yeah, these are all the things, that Tenstorrent is doing to support the RISC-V ecosystem. So let's build the future together and check out all the tools on our GitHub repository. Yeah, thanks.